Okay, this video we're going to be looking at finding the probability of being dealt 5 cards from a standard deck and getting exactly 2 pairs. Um, and so the order in which we're dealt these cards isn't going to matter, so you're going to see us using a lot of combinations. So permutations aren't going to be a big part of this, again, because the order in which you select these things doesn't matter. So when we're looking at getting our 2 pair, the first thing we need to do is we need to kind of choose the values of the 2 pair. And so there are 13 values to choose from, and we need to choose 2. So we're going to do 13 combinations of 2, or you can say 13 choose 2. It's another way that that's done. And this is using the NCR function. So we do 13 choose 2, and that will choose 2 values out of the 13. Okay, and then we're going to use the multiplication principle, because then we need a 13. We need to choose 2 out of 13, and then we need to choose from those. There are 4 of each of those values, 4 different suits, and we need to choose 2. So the first part again is choosing the value. The second part is choosing the suit. And this first part here is going to choose our 2 cards, or excuse me, the 2 values, and then 2 cards from each. So that's going to be the first 2 cards. Excuse me, the first 4 cards. And actually, we need to another 4 choose 2 in here. I forgot, because we are going to we got to choose from both of those. So this is like selecting the 2. Say this would be selecting 2 2s, and this would be selecting 2 10s or something like that, if our selections here was a 2 and a 10. So we got to have 1 4 choose 2 for each. So that's selecting the first 4 cards. Then for the last card, we don't want an overlap, so we don't, say we, again, go in with 2s and 10s, say that was what we selected, just as an example. We don't want another 2 and we don't want another 10, so that takes us down to, there are 11 values of cards left, so we need 11, choose 1 card, and then we got to multiply that by, oops, keep writing this too big, 4, choose 1, so we select the value of the card, which is this first part right here. So this is the value, and then this is selecting the suit of that last 1 card. And all of that right there is going to, I know it looks a little bit overwhelming, but all of that is how we would actually choose the total number of possible outcomes for obtaining a pair or 2 pairs. Then we're going to take that number, so you need to multiply all of that out in your calculator, and then divide all that by the total number of 5 card hands you could be dealt, which is there are 52 cards. Choose 5 of them. Again, we're using combinations because this order does not matter. So then you're going to go ahead and multiply all of this out, and you're going to get, I should say, approximately 0.0475-ish, which is about 4.75%. So that's the probability of selecting 2 pairs or getting 2 pairs when you're dealt 5 cards from a standard deck of cards. So again, we got to select the value, then we got to select the suit for each card, and then we've got to select the last value and the suit of that last value, and then divide by the total number. So now let's look and say you just wanted to get only 1 pair, so 1 2 pair, I guess we could call that, or maybe better to say 2 of a kind. You just want 1. We don't want, at least 2 cards, or you could possibly get 3 or 4. We want exactly 2, and that's all you get. So you get like 2 2s and then 3 other different cards that are all different. So we don't have any overlaps of, we're not getting two of a kinds. We're not getting a full house or anything like that. So when we look at this one, we have to, first we got to select the value. So there are 13, and we got to choose one of those values. So 13, choose one, and then we're going to times that by, keep writing this too big, choosing the suits, which is 14, choose 2. So that's selecting the pair, and then we got to select 2 of the 4 cards from that pair, and that'll select 2 of our cards. And then last, we need to select 3 different cards. So there are 12 values. We need to choose 3 distinct values of those 12. So again, if we had a pair of 2s, then that leaves us with 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King, and Ace. So there's 12 different suits or values left, and we need to choose 3 of those. So that's what the 12 choose 3 is going to pick, is those 3 different values. And then from each of those, we need to select one of the 4. So you would say 4 choose 1 for the first value, 4 choose 2 gets the suit for the second value, 4 choose 1, and 4 choose 1 gets me the value of the next suit. And then you need to go ahead and divide this monstrosity by 52, choose 5, and that will give you the actual value, or the probability of getting 1 2 pair, or 2 of a kind, I should say. I did not do this one out of my calculator, so I'm going to pause this real fast and I'll get you a number. Okay, so now once I have done this in the calculator here, I got about 0.422, and well, 226, approximately 4.226. It should be 42.26% chance of getting just a 2 of a kind, which you would expect to be much higher. It's much more likely to be dealt a single 2 of a kind than 2 pairs or two of a kinds. It's a lot of 2s in there. So hopefully it makes sense that this probability is much more significant. It's much more higher than the other because it's much more likely to occur. So hopefully that helps out in these 2 different kinds, kind of similar yet different, finding probabilities when you're dealing with a standard deck of cards. Let me know if you have any questions.